We have an employer gives an aptitude test to his employees and compares it with their productivity at work. The results are given below. All right, so we have the score on the aptitude test and we have the productivity at work. Yeah, it's a made up question. This didn't really happen, but you never know. I mean, different industries try to do different things to get the most out of their employees. So whether it's an aptitude test and productivity, or leaving fresh fruit out on the table, help yourself and productivity. Recently, and I got to add this to my list of things to do. In our faculty room here, I think it was the dean who started it. I don't know, but there's a big bowl with assorted candy in it. Like just little treats. And I look at it and say, oh, yeah, look at that. Oh, York peppermint patty. I haven't had one of those in a while. Yeah, don't mind if I do. It puts a little extra pep in my step. I don't know if I'm a better teacher because of it, but it's a feel good kind of thing. Now, how that translates to a change in productivity, I don't know if that's something that's necessarily measurable. I'm not gonna. Well, I guess I could have compared average student performance, because that would be kind of an indicator of my performance, I guess, before and after they instituted that practice, and see where that puts us. But then again, just because I have a little bit more enthusiasm when I'm delivering the content doesn't mean that you're going to go home and study extra hard because I had a York peppermint patty. So I don't know. But this does have a practical application. That's really, instead of kind of detailing every single thought that's going through my mind, I guess I could just go through the problem. But, the idea is that you can apply this in the real world. It's just sometimes you have to kind of take the vagaries of the question I present to you and, add a little bit more context, a little bit more personalized context to it. And you'll see it does fit. And aptitude tests are a thing in the school education process. Like all those weird tests, like when you were younger, that you stopped everything that you were doing, and all of a sudden it was like, all right, let's go into the cafeteria or the gym or auditorium and let's just bang out this 5-hour test real quick, and then you got the results back and it told you some information and you're like, all right, cool. What's this for? Nothing. I'm like, okay, cool. I mean, I was in the 99th percentile, so I was thrilled. I didn't know what a percentile was, but 99 sounded good to me. Then there was another one. I think it was sophomore year. We took the guidance department in my high school. They had a test that we took. It was like a not career placement, but that's the first term that pops into my mind. Just a series of questions, and based off of that, they would kind of tailor their conversations about like what colleges you should apply to, what you should consider having as a major, and things like that. So, that's another example. I mean, it's not really aptitude; it's more about interest, but it is something that could be used as a predictor. And if you can have an input that leads to a definable output, then it could be a predictor, and this technique would apply. All right, so I've yapped long enough. I put the data in. Multitasking is an important thing. So I need to draw a scatter plot, find the correlation coefficient, the regression equation, outliers, all that good stuff, and then some other things. All right, so let's start with the scatter plot. So again, that's second y equals. Now, if you didn't change any of your settings from last time, then you shouldn't really have to do anything. All right, but just in case, hit enter on plot 1. Make sure it's set to on. So enter on the word on, and then enter on the one that looks like a scatter plot, assuming that it wasn't already defaulted to that. Just make sure your alpha lock isn't on, and I'll just chuck that in here. Otherwise, you get some weirdness happening, and that's just going to happen all semester, I think, every time. All right, so zoom, option 9, to get a look at the scatter plot. Now you see I have a stray line here. I'm kind of glad it came up. I have a stray line. That's from a previous problem. All right, that'll happen. So I can go into y equals and just clear that out. That's the regression equation from the problem, the one that we finished up class with last time. So I'll just hit clear, and then I can do zoom 9 or just graph because the settings are already there. And now I have a nice scatter plot. So just hit print and tape it to your test paper, and then you don't have to worry about it, obviously. So how do we create the scatter plot? Well, you don't really need the calculator to do that for you because it's a point-by-point plot. It's an x value, comma, corresponding y value. All right, so what I'm going to do is I'm going to look at a highlighter. That's a crayon highlighter. I'm going to look at my lowest possible x value. You know, the first set of data is your x list. It looks like it's a 3, and my largest possible looks like a 20, just to get a sense of scale. And I'm going to do the same thing with the y's. Let's see here. 15 is on the low end. That's my winner. And on the high end, 70. Yeah. So when I'm establishing a scale, I just want to make sure that I get both the low number and the high number in that scale, because that's going to guarantee that everything else also falls in that interval. All right. So when I'm setting this up, I mean, I guess I could go from 3 to 20 by ones. I don't want to do that. Going out to 20 seems reasonable. So that's what I'll do. I'll make the end here 20, which makes 10 the middle value. So I'll go by halves here. Poor quality 5. Let me fix that. And then you can put individual tick marks in there. I mean, you don't have to, but I do it for my own personal convenience. Now on your y-axis, and we got to label our x-axis, but I'll do the labels all in one shot. Y-axis goes from 15 to 70. So I could do that, and if I do that, it'll match what I have on my graph on the calculator. Right? Because if I hit window, you could see, well, or more closely match. It's going from 5.65 as my y min to 80. I'm not going to do that. I'm not going to count by decimal values. So what I'll do is I'll go up to 70. And then I'll have it from there. But this is one where you don't want to go and cut it in half again. You're going to introduce a decimal value. All right? So what I would want to do, because I mean both of these values are multiples of 5, break this up into fifths. All right? So too close. All right, so we can go by sevens. I mean, it's a weird number to go by. I mean, yeah, okay, I'll do it the way you're more likely to do it. You'll probably want to go by 5, so break it up into sevenths, all right, so that you could go by 5s. All right. And by labeling just a few of them, it gives a sense of scale. So I don't have to label any more than that in terms of the numerical values. It's pretty obvious that I'm going by 5s here, vertically, and by 1s horizontally. All right, so X and Y is fine for your labels. You don't have to be any more specific than that. If you want to put aptitude test and score on aptitude test and productivity, you could do that, but I'm not requiring you to. Right? So then I think it's going to be easier to plot now, even though we're going to have to do some estimation. It's not going to be as arduous as maybe it could be. So 630 is an ordered pair, so I'll plot that. Red for those keeping score at home. 949, like here-ish. 318. 842. 739. I'm just like roughing it out. I'm ballparking it big time here. So 525, 870. 2040. 4, then 15. 11, then 45. And 1052. Some serious eyeballing. All right, but creating a scatter plot's not hard because it's just plotting x values against y values. All right. The correlation coefficient. Now, we're talking about an aptitude test and productivity at work. There's really no indication just by looking at it, or I'm sorry, looking at the framework of the question, whether or not they're talking about a linear relationship or any other type of relationship. The assumption is that any question I give you is going to be asking about a linear relationship. So basically it's going to be, is it linear or not? All right. And so here, I mean, there does seem to be an upward pattern. All right. So there does seem to be an upward pattern. So yes, upward, positive correlation. I'm abbreviating that big time. Except for the two, what seem to be outliers, it seems to be possibly linear. Possibly linear, except for outliers, which we'll get to in a few minutes. So yeah, upward, positive correlation, possible linear relationship except for outliers. You know, I'm looking at these two. Those two are kind of sticking out like a sore thumb. And they're off the beaten path. If those weren't there, I'd be very confident about the strength of the relationship. All right. But what we're going to do is compute the correlation coefficient by using the stat calc 4. So stat calc option 4, linreg ax plus b, store the regression equation into y1, so alpha trace y1. Undo. And calculate. And then you get this display, which should be pretty reasonable in terms of having the ingredients that you expected it to have. Oh, I see. If I had the pen on before I do the swipe. Of course, that little tiny dot is not. I'm sorry, my fingers are they're just bigger. I don't know what to tell you, computer. There it is. And whatever. whatever filth bag is using this computer before me, like I got chalk all over my fingers, and I'm just all I'm doing is swiping on the screen. I came over here and there was a dusty old eraser just like here, and now there's dust all over the place. And I think somebody's like they're doing stuff on the chalkboard, then they come over here and they're like emphasizing a point by clapping erasers together and like smacking it on their face and stuff like, like LeBron James before a game, So I don't know with the chalk thing in the air. I don't even know what that's supposed to be, but oh, I already did this. I'm throwing myself off my own game here. All right. Anyway. Let's see the things that aggravate me. Correlation coefficient R is about 0.444. Does it support your answer to part A? Well, kinda. Right? And that's the thing or the tricky aspect about outliers. When there are outliers in a data set, it takes your correlation coefficient and really fouls it up, all right? Because you're looking at this and that's the thing. The calculator doesn't play the what if game. You're looking at it and saying, well, what if those 2 points weren't there? That would be a beautiful fit, all right? But they are there, so the calculator has to take that into account, all right? So what's happening here is the correlation coefficient is reporting back, or the calculator is reporting back a correlation coefficient that's not very strong at all, but it's kind of giving us the sense that if those two outliers were removed, then the strength of the relationship would increase. All right. So when it says, does it support your answer to A, you could say yes, because with the outliers present, R is severely impacted. That says severely. Oh, Jesus. Let me get the stupid glove out. It just looks so bad. I'm just going to rewrite it. All right, not much better, but we'll take it. All right, find the regression equation. Well, we already did that. That's the good thing about this technique on the calculator. It's just one-stop shopping. Don't forget your y hat. Regression equation is a prediction model, and the y hat is the predicted y. So 1.546x plus 25.88844. All right, and we have to sketch this on our scatter plot. That's a weird request, but Not difficult. Not actually not, I mean, not difficult at all. Because you already have a y-intercept, so we could plot that, 25 and change, 25.8, so 5, 10, 15, 20, 25-ish. So we're looking at right around right here. We just need another point to connect it with, because hopefully we all know that in order to plot a line, all you need are 2 points and a straight edge. So we just need another point. So we could do that a couple of ways. I mean, if I hit graph, it plots the line for me, so I at least have a sense of what it ought to look like. But I just need another coordinate out of this. Now, we learned last class how to determine a y value given a particular value of x. Right? So, and this is the calculator process. Now, for the test, you're allowed a 3-inch by 5-inch index card, and I mentioned at some point in passing that most of the time people find themselves just writing calculator shortcuts. It's like little reminders of how to do things on the calculator because most everything else is pretty straightforward. This might be one of the things that end up on the list. To find y given x, second trace option 1. Second trace option 1 is value. Then it allows you to type in a particular x value, any x value you want. Now we already know what the y value is at 0, so I'm not going to use that one. I have something on the left-hand side of the graph. Why not get something on the right-hand side of the graph when x is equal to, let's say, 20?
Sorry, Professor, what did you press again?
Second trace option 1. No problem. All right. So I'm getting a y value, a predicted y value of 56 point, well, I'll just say 56.8 because I'm just using this for my own benefit to plot it on a graph. So y hat of 20, a little function notation from algebra, whatever algebra class you were in, is, and I'll use the approximate symbol here because I'm definitely not stating it's it's exactly equal to that. I almost double definite lead there. 56.8. Oh yeah, this is just going. This is going the way I want. Type in whatever number you want. So I typed in 20 just to get the y value that goes along with that. And then hit enter. All right, so second trace. You're going for the one that says value. All right, so I'm plotting 20 comma 57-ish. So that's 45, 50, it's gonna be in this neighborhood. And then I just connect them with a straight line segment. We're looking for y, given the x value. Because I just needed to plot a point. That's all. Poor quality. Do that again. I chose an x value of 20. You could have chosen anything. Because that's the function notation saying y of 20. So like f of x. So it's saying y when x is equal to 20. Right? So it's just a shorthand way of writing it so that you didn't have to write out what is y when x is equal to this. You know, it's a little bit more convenient. Some old stuff from algebra, whatever. Algebra, college algebra trig, algebra 2, if you're fresh out of high school. College algebra functions and models, but algebra. All right, so, but it's a nifty way of writing it, because basically you're saying that the x value in that y hat function is being replaced with the number 20, and this is what it's giving as a result. All right, so the next one, discuss any outliers or influential points by looking at the scatter plot. This one's simple because we've already identified them. It's just we'd want to state what they are. So in this case, we're looking at 870 and 2040. So 870 and 2040. So 870 is an outlier. $20.40 is an influential point. Explanation coming right up. All right, so it's an outlier. The 870 is an outlier because it only deviates. It only has significant deviation in the y direction. All right, so it's, you could say vertically. All right, so it's only significant deviation is in the y direction. Only significant deviation in the y direction. Maybe that'll help, I don't know. The 2040 has significant deviation in the x direction. All right, and so the next part says remove any potential influential points from your data. So only the influential points, so only the 2040, and recalculate your regression equation. Did they in fact make a significant difference to your regression line? So we're going to remove the point 2040. And then we're just going to recompute. All right. So a couple of ways you can handle that. One way is to copy the data over into L3 and L4. But I find people just generally get confused when I do that, so I'm not going to do that. If you want to know more about that, I can tell you later. And the benefit of doing it that way is that you can preserve your original data set. You don't make any adjustments to it. And so so if it turns out that you selected the wrong values to remove, then you still have the original data set in its original form. All right. What we're going to just do is delete the 20 and the 40 from the list of data. All right. So you get right onto the 20, hit delete, get right onto the 40, hit delete, and now they're good to go. That's why I made the note that we're removing the 2040, because if it turned out that that wasn't an influential point, I would need to put it back in the data set. Right, and I would want to know what that value was without having to go through all the data again. All right, so StatCalc 4. Store regression equation. Now this one you could get a little cute with, because we have the first regression equation stored into L1. I'm sorry, into Y1. If you want to be able to see the difference between the old regression equation and the new one, then you wouldn't want to store this one in Y1 also, because it would just overwrite the previous one. Right? So what we could do here is store it into Y2. So alpha trace and it's all in the same menu. So it's not much of a leap to get from one technique to the other. I mean, you could store it into any of the Ys. It doesn't really make a difference. It's just if you're always storing it into a different Y, you might have a bunch of different lines there. But I'm going to get this result. Now, hopefully you recognize this as a massive difference in the R value. Right? It's almost double. So without even looking at the picture, I can pretty solidly draw a conclusion here. I would say that 2040 is influential. About 20 minutes I'll have this word influential written out. Because the new R is almost double the old R. Right. Now, it doesn't have to be almost double. It could be almost triple. It could be like 10 points higher. It could be 15 points higher. This is the wishy-washy part of statistics. It's like there's no particular number or movement that we're looking for. It's just it was 0.444 and now it's 0.785. 0.785 is a lot different than 0.444. How much is a lot? If it feels like it's a lot, it's a lot.
So if there weren't any influential points at all, they wouldn't be asking us this question anyways.
No, they could be.
They could.
They could be, because then we would get the R value here and say it was 0.444, and let's say you recompute it and it ends up being like 0.454. You're like, well, that's not much of a change. So then we wouldn't call that an influential value or influential point. Now we can look at the picture. That was the original line. That's the new one without that influential point being plotted. And you could see that it's a much better fit to the data set. All right. So that's pretty solid visual evidence that we kind of got what we were looking for, and that is an R value. A better fit model based off of the R value. So this is the new, and this would be my old. This is page 20.